Now we are going to discuss about the first one, principal quantum number. Let me write in short form, represented by n. Okay, so this n is a positive integer. Okay, so n will be always positive, and can have value 1, 2, 3, okay, and so on. So this n represent the number of shell, okay, n1, n2, n3, okay, and then n4. So if we go on, okay, away, okay, if we move, okay, size increases, okay, if you move from n1, n2, n3, the size increases, okay, and energy increases. So energy increases, okay, so n2, n3, n4, okay, energy increases like that. So these shell are also named as K, L, M, N shell, okay, K, L, M, and N shell. So this one you have discussed in your, okay, high school also, K, L, M, N shell also. We will discuss into detail about that, okay. Okay, so this n, okay, n identifies the shell, okay, so this n will identify the shell in which the electron is present, okay. Let's see one more thing, number of orbitals in a shell. So if you are to find the number of orbitals, okay, how many orbitals are in that shell, okay, so you will be able to calculate with this, okay, n square, okay, 1 into 1, it will be 1, 2 into 2, 4, like that, okay. So you will be able to calculate with this 1 n square and electrons, okay. So how many electrons is present in that shell, okay. So for electron the formula is 2n square, okay, 2 into n square. So in that particular shell, okay, how many electrons is present, okay. So this formula will give how many electrons is present. Now number 2, okay, we have discussed about the principal quantum number. This identifies the shell. Next is azimuthal. Azimuthal quantum number represented by L. So it is also called as orbital angular momentum or subsidiary quantum number. See, this azimuthal quantum number, okay, defines the 3D shape, okay, of the orbitals, okay. So this will define the 3D shape or three-dimensional shape of the orbitals. So in these orbitals electrons are present. So L can have values 0, 1, 2, 3, okay, and so on till n minus 1, okay. So For L0, okay, the orbitals will be s orbital. Okay, for L is equal to 1, the orbital will be p. For L is equal to 2, the orbital will be d. For L is equal for L is equal to 3, orbital will be f. Okay, so from this value, okay, we can make out whether it is s orbital, p orbital, d orbital, or f orbitals. Okay, the shape of s orbital is spherical. Okay, spherical. Okay, like a ball shape. Okay, and for p, okay, dumbbell shape. Okay, the dumbbell we use for using gym and all. Okay, and then d is double dumbbell. Okay, and f is somehow complicated. Okay, it somehow look like this. Okay, it has a at-fault structure. Okay, it's somehow complicated, but it's the 3D structure, okay, of this orbital look like this as p, d, f. Okay, so in this orbital, electrons, okay, we'll find the electrons, or probability of finding the electron is maximum. For n is equal to 1, 2, 3, 4. Okay, if n is equal to 1, then L will be 0. Okay, 1, 2, 3. Okay, for n is equal to 1, L will be 0. N is equal to 2, L will be 1. N is equal to 3, L will be 2. N is equal to 4, L will be 3. Okay, now subshell notation. So for 0, okay, orbital will be s. Okay, so 1s orbital. Okay, 2, 1, so for 1, p. Okay, so 2p. Sorry, it will be 0, 1. Okay, 0, 1, 2, 0, 1, 2, 3. Okay, so for L is equal to n is equal to 1, the L notation will be 0. For n is equal to 2, for L notation it will be 2 digit will be here. Okay, 0, 1, and for 3, 0, 1, 2. Okay, and for 4, 0, 1, 2, 3. Okay, so for 0, we know that the orbital will be s. Okay, so we write 2s, and for 1, 2p. Okay, for 0, since n is 3, okay, subshell is 3, so 3, and then s, 1, 3p, 2, 3d. And for this one also, fourth shell, so 4s, 0, 4s, 1, 4p, 2, so 4d, and 3, 4f. Okay, so from this we can conclude that number of subshell in a shell is equal to number of shell. So this gives us subshell, okay, present in the shell. Okay, so number of subshell will be equal to number of shells. So 1, 1, 2, so 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so number of subshell in a cell is equal to number of shell. Okay, so for n1 is equal to, there will be only one subshell. For n is equal to 2, there will be 2 subshell, okay, subshell, okay, 2s 2p, and for n3, 3 subshell will be present, 3s 3p 3d, like that, and 4 subshell. Next one, magnetic orbital quantum number ml. So this magnetic orbital quantum number, okay, gives information, okay, written in short form, gives information about the spectral arrangement. So about the spectral orientation of the orbital, okay, with respect to, written in short form, with respect to so this will give the spectral arrangement, okay, of the orbitals, whether the orbitals pointing towards the x-axis, y-axis, z-axis, like that, okay. So m can be smaller or equal to l, okay, it can be plus minus, or simply we can write l minus, okay. You can either write plus minus also, or represent it like this, okay. Now let's discuss something like this, okay, with a table. Zero, 1, 2, 3. So for L is equal to 0, subshell notation will be S, P, D, F, okay. Now value of M, we have discussed earlier also, okay, will be 0, okay. So value of M can be from minus to plus, okay. So it will have both negative value and positive value, okay. So since 0, it will be 0, okay. This is 1, so it will start from minus 1, 0, 1, okay, for value of M, okay. And 2, so minus 2, minus 1, 0, 1, 2. For 3, minus 3, minus 2, minus 1, 0, 1, 2, 3. So this represents the number of orbitals, okay. So number of orbitals here will be 1, 1, 2, 3, so 3 orbitals, 5 orbitals, 7 orbitals, and so on, okay. So in this case, I've not written about the G and H also, okay, G and H. So since we are mostly going to discuss up to F, okay, that's why I have not included G and H. So number of orbitals 1, 3, 5, 7, okay. Let me write again. up to 3 as p d f 0 minus 1 0 1 minus 2 minus 1 0. The number of orbitals will be 1 3 5 7, okay, 9, and then so on. So this orbital is represented by box, okay, like this box. 1 2 3 1 2 3 5. So in each box, okay, 2 electrons will be present, okay. 1 2 1 2 3 4 5 6. So in each orbitals, okay, for this one 2 electrons, okay, for 3 orbitals 6 electrons, for 5 10 electrons, 7 14 electrons, okay, will be present. So number of subshell in a given number of orbitals in a given subshell can be calculated by this formula also, 2l plus 1, okay. So 2l, so if we take 0, okay, 2 into 0 0, so 1, so 1 orbital, okay. And if we take 1, 2 into 1 2 plus 1 3, so 3 orbitals. 2 into 2 4 plus 1 5 orbitals, okay. Now 2 into 3 6 plus 1 7, okay, 7. Now for the last one, number 4, electron, okay, written in short form, electron spin quantum number represented by ms, okay. So an electron spins around its own axis, okay. So electron spin around its own axis, okay. So electron can spin in clockwise, okay, clockwise direction or anti-clockwise direction, okay. So this ms, okay, spin quantum number can have value of plus half or minus half, okay. So we can either assign plus half or minus half, okay, for clockwise or anti-clockwise, okay. You can assign, if you assign plus half for anti-clockwise, then you need to assign minus half for clockwise, okay. So it depends on you to assign this one, okay. So this orbital is represented by a box and the electrons are filled in that orbital like this, okay. One arrow pointing upward and the other pointing up downward, okay. So either can have positive or negative, okay. Suppose if you say this upward is this arrow pointing upward is positive and this one negative, okay. So they are opposite, okay. Positive and negative, they are opposite, okay. So we are writing this electron, okay, one upward and one downward, okay. So if you write this electron like this, then it will be wrong. Okay, so an orbital cannot have more than 2 electrons. Okay, 2 electrons. Okay, one pointing upward, one pointing downward, and it can have this plus half and plus minus half. Okay, and it cannot have more than 2. Okay, it cannot have 3 electrons in that orbitals. Okay, so from this we can conclude that, okay, these quantum mechanics give the highest probability of finding an electron. Okay, and we know that electrons are found in the orbitals. Okay, so through this calculation, okay, through this we can find out in which orbital the electron is present. Okay, so one question is given in your textbook. Okay, using SPD notation, describe the orbital with the following quantum number: n is equal to 1, L is equal to 0, B, n is equal to 3, L is equal to 1, C, n is equal to 4, L is equal to 2, D, n is equal to 4, L is equal to 3. So solution: for L and L, okay, and L 1 1 3 1 3 4 4, okay. A, B, C, D. So 1, L is equal to 0, 3, L is equal to 1, C, L is equal to 2, D, L is equal to 3. So we are to assign the subcell notation, okay, S, P, D, F and all. Okay, so for 0 we know S. Okay, since 1, so 1S. 3 3, okay, 1 will be P, so 3P. 4 4, okay, 2, after P D comes, so 4D. 4 4 4 subshell, so 4 3, so SP D, next will be F, okay, 4F.